Hello students, in the previous video I discussed about solving problems on chemical equations applying mole concept. We are continuing with that, problems on chemical equations. Today I have some more questions on that. Let us see this. Here is a question. Ammonia may be oxidized to nitrogen monoxide in the presence of a catalyst according to the following equation. The equation is given in the question. Now it is mentioned if 27 liters of reactants are consumed, what volume of nitrogen monoxide is produced at the same temperature and pressure? Also find the mass of water produced in this reaction at the same time. Now, so this question, they have actually mixed up the reactants together. 27 liters of reactants. So that means, let us write the reaction 4NH3 plus 5O2 gives 4NO plus 6H2O. Now when they are saying 27 liters of reactants, now you see these are gases. This is ammonia is gas, oxygen is also gas, product nitrogen monoxide is gas, this one is liquid water. Okay, so they are saying 27 liters of reactants. The reactants here are ammonia and oxygen. Together, how many moles are there? This is 4 moles. This is 5 moles. So it is 9 moles. 5 plus 4, 9 moles. Understood? They are taking it together. So I am also taking it together. And because they are saying reactants, they are not giving the value of each one of them. Okay. The product side, we have 4 moles of nitric oxide or nitrogen monoxide and 6 moles of water. Okay. Now, what is to be found? They are asking what volume of nitrogen monoxide. That means this one is asked. This is X. Okay. And what is the other thing asked here? Also find the mass of water produced. So this is Y. Okay. Now let us take what is given here. Now since this is a gas, we can convert 4 moles means 4 into 22.4 liters. Okay, these are gases. 9 moles means 9 into 22.4 liters. Okay, and this side we have water. Here the mass of water is square Y. 6 moles means 6 into, you know, the molecular mass of water. Hydrogen is 1, oxygen is 16. So the 2 into hydrogen is 2. So that is 2 plus 16 is 18. Okay, so we have 18, 6 into 18 grams. Okay, so this is the ratio. 9 moles, that is 9 into 22.4 liters, and 4 moles, 4 into 22.4 liters upon X, 6 into 18 grams upon Y, and this here we have 9 into 22.4 liters, and what is given upon 27 liters of reactant, 27 liters. Okay, so this is the situation. Now let us calculate one after the X and Y. 2 things are to be found. So first one, let us take volume of nitrogen monoxide. Nitrogen monoxide. Okay, so how do you find? The ratio here is 9 into 22.4 upon 27. So this is the ratio here. Now equate with the NO. NO is here as 4 into 22.4 divided by X. So what is X? Cross multiplying. X is equal to 4 into 22.4 into, this will go other side, reciprocated, 27 upon 9 into 22.4. Okay, we can cancel since it is a fraction. 22.4, 22.4 gone. 27 and 9, 3. So what is left? 4 into 3. That is 12 liters of nitrogen monoxide is formed. I think it is very easy. You understood? The problem is only finding here because they are given reactants together. We have taken it together. The other things is same as we have done in the previous question. The next part of the question is mass of water produced. So let us find out mass of water. Mass of water. So, okay, so what will be the ratio? The ratio we will take from here, 9 into 22.4, 9 into 22.4 upon 27, that is equal to, the ratio for water here is 6 into 18 upon Y. 6 into 18 upon y. So from here, cross multiplying, find out what is y. Y is equal to, y comes this side. Here you have 6 into 18 into, this will go there as reciprocated, 27 upon 9 into 22.4. Okay, 27 and 9 cancels, 3, and anything else will cancel. So let us see. We have 22.4 here, and 6 and 18 here. So maybe we can cancel this 9, and this will become 11.2, and 6 can be cancelled as 5.6, 11.2 and 5.6, and this will become 3. So 5.6, that is equal to 3 into 9 into 3 upon 5.6. So finally you can divide it. Okay, so you will solve this one. So simplify it. Yeah, so that is equal to, you can find out, 3 3s are 9, 9 9s are 81 upon 5.6. So you will find out the answer by dividing. Okay, 81 divided by 5.6. So you can find this one 1. So 5.6, you will get 56. Maybe you can take as 56 already, you can put here 10. So by dividing you will get 81 divided by 5.6. So 1, and or you take it as a whole, you will get 14 here, 14, and then the decimal values will come 14.4, yeah, 14.46. So 14.46 will come. So you can divide and find out what exactly comes there. Okay, now let us go back and see what exactly we have done here. So in the first case, we have taken these volumes together because they are saying reactants, together the value is given. The rest is same as in the previous question. So we have divided and found the value. Now let us take another question here. The next question here is aluminum carbide. So let us take aluminum carbide. Aluminum carbide reacts with water according to the following equation. Al4C3 and 12H2O will give 3CH4 and 4Al whole thrice. Now calculate the volume of methane measured at STB released when 14.4 grams of aluminum carbide reacts with excess of water. Now also find the mass of water used. So two things have to be found here. So the reaction is Al4C3 plus 12H2O. It is a balanced equation. So it gives 3CH4 plus 4AlOH whole thrice. Okay. Now applying the mole concept, this is 1 mole, this is 12 moles, and this is 3 moles, and this is 4 moles. Okay. So here aluminum, the weight of aluminum carbide is given. So we have to find out the molecular mass of this Al4, that is 27 into 4. Okay, Al4, and C3, that is 3 into 12. This is 36. So this will be 108. Okay, and adding 144. Okay, 144. So molecular mass of this one is 1 into 144 grams. And water we are not touching because not required here, not asked here. Calculate the volume of methane. Methane is required. So 3 into 3 moles converted into moles, 22.4 liters. Okay, and then we have also find the mass of water. So water required. Okay, water is asked. So 12 into mass of water is 18 grams. Okay, we already know, we have calculated in previous questions. Aluminum hydroxide, yeah, this is not asked, so let us leave it. So now what is given here? 14.4 grams of aluminum carbide is given. This one is X and this one is Y. Okay, so let us now calculate. Number one is volume of methane. Volume of methane is equal to what you have, 144 upon 14.4 is equal to 3 into 22.4 upon Y. So what is Y? Now Y is equal to 3 into 22.4 into 14.4 upon 144. Okay, so this goes 10, so this will be divided by 10, so that is 2.24. So 3 into 2.4 is 6.72 liters. Answer is there, 6.72 liters. Now the second part of the question is mass of water. Mass of water. Mass of water, how do you calculate mass of water? Now here you have 144 upon 14.4 is equal to 12 into 18 upon X. So what is X here? X is equal to 12 into 18 into 14.4 upon 144. 14.4. So this goes 10. Okay. So this can be multiplied. That is and then divided by 10. That is equal to 12 into 18. So how much is 12? 18s are in 180 and 36. 216 upon 10 is equal to 21.6 grams. Okay. So that is the answer of this question. Now I have one more question here. The third question as example, because this is only for practice. So keep practicing these questions. Here we have solid ammonium dichromate reacting. NH4 hold twice Cr2O7 giving N2 plus Cr2O3 plus 4H2O. Okay, this equation. Three things are asked. Calculate the mass of nitrogen release. So this is required one thing. And then mass of chromium 3 oxide. This is also required. And then what will be the mass of water produced? This also is required. So that means everything is to be found. Ammonium dichromate. So here the molecular mass of ammonium dichromate. Ammonium dichromate NH4 hold twice Cr2O7. So this is the formula. So let us calculate the molecular mass of ammonium dichromate first. Ammonium dichromate NH2. So this 2 applies to both. So there will be 2 nitrogen. So 14 into 2 is equal to 28. And 2 4s are 8 hydrogen. So 8 into 1 is equal to 8. And then chromium, 2 into chromium, the atomic mass is 52, is equal to 104. And then oxygen, 7 into 16. So 7 into 16. 1, 1, 2. Okay. So let us add this. So on adding what you get, that will be the molecular mass. 6. 252. So this is 1 into 252. This is 1 mole, we know. And so I'm doing directly. And this will be 1 into 22.4 liters. This is molar mass, 1 mole. Now this is 1 mole of chromic oxide. Chromic oxide 2 Cr. That is 2 into 52 is equal to 104. And oxygen 3 into 16 is equal to 48. On adding, what you get? So 152 is there. So this will be 152 grams. This is also grams. This will be 4 into 18 grams. So everything is there now. So now we can start. The number 1, that is part A, is volume of nitrogen. Into is equal to, what are the ratio we are taking? Now what is given here? 31.5 grams of ammonium dichromate. This is 31.5. This is X, this is Y, this is Z. Okay. So that is 252 upon 31.5 is equal to volume of nitrogen 22.4 upon x. Cross multiplying, x is equal to 22.4 into 31.5 upon 252. Okay. So we now have to find. So this will divide 8 times. Okay. 8, no? Exactly 8. Yes, it is 8. Okay. Now, what will be the answer? This can be divided by 22.4. This will be 4 divided 11.2. Again divide 2. This will be 5.6. Again cut by 2. That is 2.8. So it's equal to 2.8 liters of nitrogen. Got it? So everything is cancelling on its own. So you can see that. Second part is mass of chromium 3 oxide. Mass of Cr2O3. How do you find out mass of Cr2O3? So from the ratio, it will be 252 upon 31.5 is equal to the right side Cr2O3. Here we have 152 upon Y. 152 upon Y. Okay. So what is Y? Y is equal to 152 into 31.5 upon 252. As I said, this is gone by 8. Now this can be cut. So this will become 4 and 76. Again 2 and 38. Again 2 cancel by 19. So answer is 19 grams. Okay. And then the last part of the question, that is last part is, what will be the mass of water produced? Mass of water. Again the ratio will be 252 upon 31.5. This will always remain because that is the value given on both sides. This will always be there. Now water will be 4 into 18 upon Z. Okay. So 4 into 18 upon Z. Okay. Now what is Z? Cross multiply. Z is equal to 4 into 18 into 31.5 upon 252. As we have cancelled already, this is 8. Okay. Now 8 and 4 will be 2 and 4, or 2 and 2. Okay. Now 2 upon 18, 2, and this will go 9. So it's equal to 9 grams. Answer is 9 grams. Okay. I think that is clear. One more example, another typical example here. So we can find out this question. Concentrated nitric acid reacting with phosphorus to form phosphoric acid as follows. So let us write this reaction. So this is P is 1 mole. This is 5 moles. And this is 1 mole. And this is 1 mole, 5 moles. Okay. Now atomic weights are given here. Hydrogen is 1, nitrogen is 14, oxygen 16, phosphorus 31. So using that we can calculate 1 mole of phosphorus is 31 grams. Nitric acid 5 moles into HNO3 on calculation comes 63 grams. And phosphoric acid 1 into 98 grams. And 1 into 18 grams. This is 5 into 22.4 liters. This is gas in volume. This is not mass. Okay. So these are the ratios we have. So you can sit and calculate how these molecular mass came. I have already shown you, so you know. Using these atomic weights, and you calculate, that's what you get. We are finding each of this. Now they are saying mass of phosphorus prepared from 6.2 grams of phosphorus. So the weight given here is 6.2 grams of phosphorus. So this is X, this is Y, this is Z, and this is P. So 31 upon 6.2 is equal to 5 into 63 upon X, that is equal to 1 into 98 upon Y, that is equal to 1 into 18 upon Z, that is equal to 5 into 22.4 upon P. So these are the ratios we have. Now let us calculate. Number 1, A is phosphoric acid, mass of phosphoric acid H3PO4. So what do we take? So mass of phosphoric acid is here. So this one along with the first one, 31 upon 6.2, 31 upon 6.2 is equal to, what is your phosphoric acid? 98 upon Y. 98 upon Y. So what is Y here? Y is equal to 98 into, this will go other side, reciprocated 6.2 upon 31. Okay. So how do you, this will be 5 times cancelled. Okay. So because they will be in ratio, always look for that ratio instead of dividing the other numbers. Okay. So 98 upon 5, that is equal to, how much it will be? 98 upon 5. You can divide it or you can cancel it. 98, 20, 19.5 grams. Okay, you can divide and find out. Now, second part is nitric acid, mass of nitric acid. Mass of nitric acid. Okay, again the ratio will be 31 upon 6.2 is equal to, the right side will be, this is as it is, mass of nitric acid is here, 5 into 63 upon X. 5 into 63 upon X. Okay, so what is X here? X is equal to, we will bring to the other side, 5 into 63 is as it is, this will go to the other side, 6.2 upon 31. As we have cancelled already, this will be 5, this 5 and 5 cancelled, is equal to 63 grams. Answer is done very easily. Now the third part of the question, volume of nitrogen dioxide, volume of NO2. Again the ratio will be 31 upon 6.2 is equal to, now we will find the NO2 ratio here. Here it is 5 into 22.4 upon P. That is 5 into 22.4 upon P. Okay, so what is P? P is equal to 5 into 22.4 into 6.2 upon 31. So this will go 5 times, this 5 and 5 goes, so answer is 22.4 liters. Very simple. Okay. So I hope you got it, children. Now you can solve these questions again and again to get more practice. And we'll see you in the next video. Thank you.